Hi folks, I'm Emmanuel from Sematic. This is a quick video to give you an overview of what Sematic is and how it works. So let's get started. Sematic is an open source framework to build and execute end-to-end machine learning and data science pipelines faster than you've done before. So why do you need Sematic? Maybe you've been building models in Jupyter notebooks and you're finding limitations to your workflow and your collaboration with your coworkers. Maybe you want to build testable, reproducible, and traceable pipelines for greater safety and robustness. Maybe you want to automate your model to train weekly or daily. You want to be able to retrain and visualize all your assets. For all those reasons, Sematic is here to help you. Now, who is building Sematic? Sematic is built by a team of engineers with experience both in academia at institutions such as CERN and the US National Labs, but also in industry at companies such as Instacart or Cruise. So what is an end-to-end pipeline? Typically, when you're doing machine learning or data science, you start with raw data. Raw data typically sits in your data warehouse or in your production database, and the final product of your work is typically predictions that you use either directly in your app or to make decisions in your company. In between, you have an end-to-end pipeline. Now, let's take a deeper look at what that entails. Typically, an end-to-end pipeline starts with data processing, where you're converting your raw data into a feature dataset that you can use to train your model. Then you pass your feature dataset to a training and evaluation step, where you train your model, you evaluate performance, and eventually you pass your trained model to a testing and simulation step, where maybe you send some production data to your model to make sure that there are no regressions and that the model performs as expected. And finally, you may want to deploy your model. That can mean generating inferences and storing them in a database table that is called batch inferencing, or it could be real-time inferences where you deploy your model behind an endpoint that you can query from your production app. This is a simplistic view of an end-to-end pipeline. Let's take a deeper look at one of those steps. Let's focus on the data processing step. Raw data comes in, and typically the first thing you want to do is to clean the data. You want to remove outliers, you want to filter, and so on. Then you want to pass this clean data set to a data transformation step that may want to, for example, rotate images, normalize distributions, one-hot encode classifications, and so on. Now your transform data is passed to a featureization step that will prepare your data in a format that your model can understand. The output is a featureized data set. Now in the process, you may want to generate some metrics and publish to a metrics dashboard for the rest of your team to look at. Now, this is just the data processing step. If we go back to our end-to-end pipeline, what looks like a pretty simple process at a high level, in reality looks more often like this, with many sub-steps, many nested steps, and many side effects. So why do you need an end-to-end pipeline in a first step? You could be doing all those steps by hand and then moving on to the next. The first reason is reproducibility. If your model is generating predictions for your production app or for decisions for your company, it's important that you're able to reproduce your model so that you can debug or investigate issues. Also, if new people join your company, they may want to rerun a particular pipeline so as to experiment with new inputs and so on. Then you need to be able to test your pipeline. Each of your steps needs to be unit tested for greater safety and reliability. Then you want to track everything so that you have an exhaustive bookkeeping of everything that went into training your model and generating your inferences. This is especially important if your business requires some sort of legal compliance. Then you want to be able to visualize all of the inputs, outputs of each of those intermediate steps so that you can investigate issues, debug, and so on. And finally, you want to automate the training. Maybe you're getting new data every day or every week, and you want to be able to easily retrain your model so that the predictions remain relevant to the real-world conditions. Now, if we go back to our end-to-end pipeline, Sematic helps you define all those steps by simply using Python functions from the most deeply nested steps to their encapsulated high-level steps to the entire end-to-end pipeline. You use Python functions to define the business logic, the execution flow, as well as the data dependencies between all those steps. That makes it much easier. Now let's take a look at how you can convert an arbitrary function into a pipeline step. This is a very basic toy function that takes in two inputs and returns an output. The first step to convert this function to a Sematic pipeline step is to decorate it with the Sematic decorator. Once you do this, all your input artifacts, your output artifacts are type checked, tracked, and visualizable in the Sematic UI. Also, when you execute a Sematic function, it is tracked as a run, along with its associated artifacts, its code, and third-party dependencies. Now let's take a look at a more realistic example. Here is a train model function that expects a config input, a train loader, and trains the model and returns it. The input artifacts in this case are the config that you can visualize in the UI, the train loader, PyTorch device, and your final train model. Let's take a look at another example. This evaluate model function expects a PyTorch model, a test data loader, and computes evaluation results and returns a data class containing a bunch of metrics and a couple of plotly figures. Now this function is also traceable and visualizable in the UI, where each of the metrics are surfaced directly there, along with the plotly figures for the confusion matrix and the PR curve and so on. Now let's go back to our end-to-end pipeline and take a look at this train eval step. And let's try to build this with the two functions that we just saw. So this is it, simply building another function that encapsulates calls to train model and evaluate model, which results in the graph that you see here on the right. Now we can also include this train eval sub-pipeline into our end-to-end pipeline. In this case, we have a couple of calls to load an MNIST dataset, featurizing the dataset into a data loader for our model, and then calling our sub-pipeline to do training and evaluation. And that's it, just as easy as writing simple Python. Now you want to have an iterative development workflow where you change code, you run your pipeline on a small amount of data, typically 1 to 10% of your dataset locally to make sure that everything looks okay. And then you want to submit your job to run in the cloud, to run on the entire dataset. And eventually you want to visualize, and you want to keep doing this in the most efficient manner so that you can get your results faster. Now, Sematic lets you do this by using the local resolver to execute your pipeline locally, then executing at scale by using the cloud resolver. You can also have an iterative development while running in the cloud. You can change code locally, then submit your job. Sematic will take care of packaging your code and dependencies, shipping your build to the remote cluster, executing your pipeline according to the resource requirements you've specified in the code, and then you can visualize and keep iterating as such. Now, whether you're running locally or remotely, you can track all of the execution and the inputs and outputs of your jobs and each of the steps in the Sematic UI, where you have access to the output artifacts here, and you can also visualize the entire execution graph of your pipeline. You can get started very easily by simply pip installing Sematic and launching the web app locally. Then if you want to deploy Sematic in your cloud, you can do so if you have access to a Postgres database and a Kubernetes cluster. That's it for now. Thanks for watching. Check us out at sematic.dev, star us on GitHub, and if you have any questions, join us on Discord. Find the link in the description below. Thanks. Bye.